Good evening, Earth Science students. Tonight's teaching point to make connections between energy in the Earth processes and meteorology to climate. Alright, during the course of this video, open up your notebooks, write your teaching point in a table of contents, write your teaching point for your notes, and the notes that are in yellow font must be in your notes. And I'm going to this time give you a guided note packet so you can fill in the missing important terms. And once again, I will supply you with vocab terms. Make sure that's in the back of your book for this unit on water and climate. Okay, what is climate? Climate, the overall view of a region's weather conditions over long periods of time. It includes not only averages, over the course of a year, but also extremes. Your extremes can be like desert-like conditions where it's really hot during the daytime and really cold during the nighttime. Alright, you have your tropical zones right near the equator. Right, you have the Tropic of Cancer and you have the Tropic of Capricorn. Right, so you have your tropical zone near the equator. We have our temperate zones for most of the U.S., if not all of the U.S. Europe, parts of Asia, and Russia. We have southern part of South America, southern part of Africa, and most of Australia and New Zealand. We have our polar zones. We have Greenland, northern Canada, northern Russia, and we have all of Antarctica. Alright, factor 1, latitude. As latitude increases from north and south of the equator, the temperature decreases. Alright, so as you go north and south of the equator, your temperature is going to decrease. Now this holds true for a certain season, like the equinoxes. We'll learn with astronomy that on June 21st, this factor really pertains to the Tropic of Cancer. So anything north or south of 23.5 degrees north latitude will have a decrease in temperature. On December 21st, the Tropic of Capricorn, anything north and south of the Tropic of Capricorn will have cooler temperatures. Okay, factor number 2, humidity. Based on the planetary wind belts, at 0 degrees, 60 north, 60 south, will give you high relative humidity, your wind belts. 30 north, 30 south, 90 north, 90 south will give you low relative humidity. Those are your dry belts. So at 0, that will give you your tropical rainforests. At 60 north and 60 south, that will give you your temperate rainforests. At 30 north and 30 south, that will give you your very hot desert climates. 90 north, 90 south will give you your very low temperature desert-like climates. Factor 3, prevailing wind patterns. There are 6 sets of wind belts for the Earth. 3 of them are in the southern hemisphere, right? We have the southeasterly winds, the northwesterly winds, and the southeasterly winds. In the northern hemisphere, there are 3. Northeasterly winds, southwesterly winds, and the northeasterly winds. Okay, other areas of the world are in different wind belts. Australia, southern hemisphere, different wind belt than the U.S. Greenland, right, north of us, different wind belt altogether. All right, so the U.S., our winds come from the southwest and blow toward the northeast. Every high and low pressure system gets pushed across the U.S. from the west to the east. Okay, factor 4, surface ocean currents, found on page 4 ESRT. Warm ocean currents will give you a warm and humid climate. Cold ocean currents will give you a cold and less humid climate. Remember, warm air can hold more water vapor. Cold air can hold less water vapor. Alright, so once again, this is the scheme for the surface ocean currents on page 4. there are two currents, it's warm and cool. For instance, like the Antarctic Circumpolar Current, right? This current goes all around the Earth, but according to the key, this is a cool ocean current. Let's bring this back to the U.S. We have, on the West Coast, we have the California Current, which goes southward, and that's a cool current. On the East Coast, we have the Florida Current that goes through the Gulf of Mexico, and then that turns into the Gulf Stream Current, which takes and transports warm water across and into Europe and Britain. Alright, so here's a question. Alright, just pause it right now, take a few minutes to read it, and then we have a question. Identify the ocean current off the northeast coast of Australia that most affects the climate of Mbe Island. Alright, so this island is found, according to the reading, at 15 degrees south latitude and 168 degrees east longitude. So we take that location and we go to the reference table. Right? First of all, we're going to find 168 degrees east longitude, right, which is in the eastern part. So you want to go right here, 0 degrees longitude, right, that's going to be the east side to the right, which continues on the other side. And then we're going to find our 15 degrees south latitude, and where the two matches up, that can give us an ocean current. This island is located near Australia, right, and somewhere near New Guinea. And where the two meet will give us a current called the East Australia Current, or East Australian Current. Alright, so the answer to this question would be the East Australian Current. Alright, let's move on. Factor 5, large bodies of water. Water has a high specific heat, which means that it absorbs and radiates energy slowly. Much slower than lead, right? Lead, we said in class, has the lowest specific heat, which means that it heats up, it takes in, and gives off energy quickly. In addition to this, water will moderate the climate, which means that you would have cooler summers and warmer winters. That's true for the eastern and western coast of the U.S. The further inland you go, away from the water, that's your extremes. You would have, in that case, you would have warmer summers and cooler winters if you're far away from water. Factor 6, elevation. Temperature, pressure, and water vapor concentration decreases as elevation increases. Alright, this really, this holds true to the troposphere, and that's our concern right now, the troposphere. Alright, so temperature decreases in the troposphere as elevation increases. Pressure decreases in the troposphere as you increase elevation. Same thing with water vapor concentration. It's going to decrease in the troposphere as elevation increases. Factor 7, mountains, also known as the rain-shadow effect. Okay, we have two sides of the mountain. We have the windward side and the leeward side, like a sand dune that we learned about during erosion and deposition. Notice prevailing wind on this diagram is here. It's going from left to right. It's going to hit the mountain on one side, which would be your windward side, right? So we have rainy windward slope. On the other side, we have our leeward side, which is opposite. So as this moist air rises, it's forced to become cooler, and it's forced to condense to form clouds and precipitation. So on the windward side, we have our cloud formations and we have precipitation. All that happens there. On the other side, on the leeward side, we have warmer temperatures now. Now this air mass begins to sink. Gravity pulls it down, and therefore would compress. It's forced to compress, and it's forced to become warmer. So on the windward side, we have cool air. It rises. It's forced upward, and it's moist. Right? You have cloud formation and precipitation. On the leeward side, you would have warm air. It sinks. It's forced to go down, and it's drier. Drier conditions. Good example of this, I believe this is part of Hawaii, and we have the windward side. So notice, right, so over here we have some sort of continental divide, right, or a mountain peak. So the air mass comes up, we have all these cloud formations here on the windward side, a lot of precipitation. Notice a lot more green on this side, on the windward, than on the leeward. It's almost like desert-like conditions on the leeward side. So there's less precipitation on the leeward and more precipitation on the windward side. Right? This is a great example of what we call the rain shadow effect, based on mountains and how the wind pushes it up, how it forces it up and forces it down. Factor 8, vegetation. Tropical and temperate rainforests give you high transpiration. Remember, plants not only give off oxygen, they also give off water vapor, right? That's transpiration. All right, so we have high transpiration and the greater chance of condensation and precipitation. All right, so vegetation plays a major role in this too. All right, last factor, number 9, cloud cover. All right, too much cloud cover can reduce insolation. Remember, insolation stands for incoming solar radiation. So clouds can absorb insolation and they can reflect insolation, which reduces the amount reaching the Earth's surface. Remember, the Earth has to absorb that energy as short waves, and it gives it off as longer wave infrared, which is heat. All right. In addition, violent volcanic eruptions. Right. So if you have a major volcanic eruption, like in this picture, that's going to give you a lot of dust and debris in the atmosphere. Almost like a cloud, right? It will absorb and reflect insolation, reducing the amount that reaches the Earth's surface. All right, which would in fact also make it cooler, at least on the Earth's surface. High pressure conditions, right, where the sky is clear, right, clear blue skies, you would have an increase in insolation, right? So the Earth can absorb a lot more insolation that way. All right, guys, that will conclude this. I'll have questions set up for class tomorrow. You'll have 2 questions for your quick assessment, and then for your activity, you'll have about 21 questions to work on. Have a good night, and see you tomorrow.